Students, welcome to Global Virtual School. This is your chemistry first year class. I am Dr. Banu. Our chapter is second, that is atomic structure, and the topic for today's discussion is discovery of nucleus. Students, up till now we have learned the discovery of electron, proton, and neutron. But now is the discovery of nucleus. And students, you already know that in a simple atomic structure, nucleus is the central part of the atom in which protons and neutrons exist, while electrons revolve around this central part that is called the nucleus. And students, after completing this topic, you will be able to understand the experiment, how it was discovered, how nucleus was discovered, and what is the name of this model that was given by the Rutherford. And we will also discuss the defects of the Rutherford's atomic model. You will be able to find out the defects, the things which were not explained by the Rutherfords. Students, up till we have learned discovery of electron, proton and neutron. But the location of electron, proton and neutron in an atom was doubtful. Where electron exists in an atom, where proton exists, and where neutron exists. So for that purpose, Rutherford performed an experiment, and in the way he discovered the nucleus. His experiment for the discovery of nucleus that by Rutherford, it consists of the following part. This one, first it has some alpha particle source. I already told you in previous lecture that alpha particles they emit from radioactive element. In this case, he used the radium as radiation source. Even polonium can be used as radiation source. These are radium and polonium, both are radioactive elements, and they emit the alpha, beta, gamma radiations. This was placed inside a box, and they emit the alpha particles. What he did, he strike the alpha particles on a thin gold foil, very thin. Its thickness was almost 0.0004 centimeter thickness. It's very thin foil of gold. All atoms are in metals, atoms are very close to each other, and its thickness is very low thickness. And he just bombarded the alpha particles on this gold foil, and he observed the effect of its bombardment by putting a photographic plate around it. You can also call this fluorescent screen. When these alpha particles strike on this fluorescent screen, they produce some glow where they strike. And what he observed during this, he observed that some of the alpha particles passed straight and they produced glow in front of the alpha particles, and it is without any deflection. Some were deflected at a smaller angle, some were at larger angle. I will just zoom out this thin gold foil to make it more clear for you, like this. These are the gold particles, and I will zoom out more for you. Okay, come to this smaller portion of the gold foil. This one is gold foil, and here just we are showing few atoms to you. This is the atom of gold. It has nucleus. Nucleus contains proton, positive charge, and neutron. This is another atom, and in metals all atoms are close to each other in this way. This is the nucleus. Nucleus contains positive charge by proton and neutron, and these are alpha particles. Alpha particles, helium nuclei, they have two protons in the center, and these alpha particles I already told you obtained from, in this case, from radium source. A radium is radioactive element, and these alpha particles they bombard on this gold foil, thin gold foil, and in front of it are lot of gold particles, lot of gold atoms that contain a heavy nucleus, and this outer portion that contains the electron. And what he observed, some of the particles they pass straight. And how he observed this? By putting a photographic plate around it. Some of the showing no deflection, they just producing flash as it is in a straight way. but some shows a deflection at a small angle. Some were showing deflection at little more angle, like this one, and some of them just turn back. Just they turn back, and it shows that like positive portion is repelling and just turning it back, straight away back. So he observed different, like some of passing straight, some are deflecting at small angles, some are deflecting at little larger angle, and some are deflecting just return back. And he observed on some fluorescent screen, and on the base of its observation he concluded that an atom consists of a very small, heavy and positively charged portion called the nucleus. Most of the part of the atom is empty, but on the base of this deflection, he concluded that very small, that is heavy, and that must be positively charged. Why positively charged? He concluded because helium also contains positive charge, and this is like repulsion. So same charges repel each other. So he concluded that a very atom contains a very small, heavy and positively charged portion, and gave this part the name nucleus. Like this is the atom, this one center part, and around it the electron is revolving. And there is negatively charged portion which surround the nucleus containing electron called extranuclear portion, or this is called planetary. Other than this part of the atom, this is the nucleus, and under this part where electron is revolving, because the electron is revolving in 3-dimensional. So this part is called extra nuclear portion, or this is called planetary, and its model also gave the name planetary model. And the number of protons are equal to the number of electrons in this planetary model. Why? Because neutron is neutral, and if central part contains positive charge, there must be an equal negative charge, because overall atom is neutral. That's why he concluded that protons are equal to the number of electrons in this planetary model, and this is true. And electrons revolve around the nucleus. Of course, I already showed you in the diagram that electron is in continuous revolution around the nucleus, like this. And in this case, centripetal force is equal to the electrostatic force of attraction. If they are imbalanced, then they must be attracted by the center, or they must repel by the center. But here he concluded that both forces, centripetal force and electrostatic force of attraction, they are equal, and only a very small volume is occupied by the nucleus. In overall atom, small volume is occupied by the nucleus. All other, most of the part is empty where electron revolve. So that there were some things that were not explained by the Rutherford, and that's were called defects of Rutherford's atomic model. Rutherford's atomic model is based on the law of motion and gravitation, and these laws are applicable to the neutral bodies, but these cannot be applicable to the electron, proton. These are that are charged particles. So this was not explained by the Rutherford. Similarly, according to Maxwell theory says any charged particle moving in circular path must radiate energy continuously, and ultimately the electron must be spiral, for it must be moving, and its spiral path will be close and close to the atom, and ultimately it should fall into the nucleus. It means the atomic structure is collapsed like this. We consider this is electron that is revolving around the nucleus, and according to Maxwell theory, it should be in a spiral path should be smaller and smaller, and during this radiations are emitted, and its path becomes closer and closer and closer to the nucleus, and ultimate electrons should fall into the nucleus. Then the atomic structure will be collapsed, but actually it does not happen. So Rutherford could not explain how it is existing atom in this form. Electron is not falling in the nucleus. These defects were later discussed by other scientists. And if electron emit energy continuously, if then it should form continuous spectrum. Spectrum basically is the visual display of the light. When a spectrometer is placed in their path, they split into different wavelengths radiation. So in this case, when the if consider if electrons emit radiations continuously, then their spectrum should be continuous. But in actual, what was observed, line spectrum is obtained. Spectrum is not continuous. This will also be discussed by other theories in our upcoming lectures. So these were some points that were not explained by Rutherford's atomic model, and later they were explained by other theories. And the questions usually asked in this topic are, which particles are present in nucleus? Of course, we have repeated this so many times, you must be like on your fingertips, protons and neutrons that are present in the nucleus. What is the other name of Rutherford's atomic model? Of course, its atomic model, it is the planetary model. And why other Rutherford's atomic model is defective? You have to discuss the defects of the Rutherford's atomic model. Students, in today's topic we have discussed the experiment for the discovery of nucleus, Rutherford's the atomic model, and also discuss the defects of Rutherford's atomic model, which will be removed by in our next topics, including Bohr's atomic model, and we will discuss the Bohr's atomic model with its applications.